We tend to think of space as this vast, silent, empty blackness, punctuated by the occasional serene twinkling star. But that picture is profoundly, beautifully, and terrifyingly wrong. The universe isn't just a quiet void, it's a chaotic, dynamic, and utterly bizarre cosmic laboratory, where the laws of physics are pushed to their absolute limits. Today we're peeling back that serene veil. We've compiled a list of facts so mind-bending they sound like science fiction. Each one is a portal to a different corner of cosmic insanity. So, get comfortable, and prepare to have your understanding of reality fundamentally rewired. Space is about to get actually insane. Let's start with something small, or rather, something small that contains an impossible amount of big. A neutron star. These are the collapsed cores of massive stars, and they are density incarnate. A single teaspoon of neutron star material would weigh around 6 billion tons on Earth. That's the equivalent of a mountain, or every single human on the planet, crushed into a volume smaller than a sugar cube. The gravity is so intense that the very atoms we're made of are obliterated. Protons and electrons are forced to merge, creating a pure ball of neutrons, packed shoulder to shoulder. It's matter on the absolute brink of collapsing into a black hole. Now take a neutron star and give it a magnetic field a quadrillion times stronger than Earth's. You get a magnetar, the most powerful magnet in the known universe. Its magnetic field is so extreme it could wipe the data from every credit card on Earth from the distance of the moon. But it gets weirder. The immense stress of this magnetic field can cause the star's solid crust to crack and shift in an event called a starquake. This seismic event is so violent it releases more energy in 1/10 of a second than our sun has in the last 100,000 years, sending out a blast of gamma rays across the galaxy, from extreme energy to extreme cold. The background temperature of space itself is a chilly 2.7 Kelvin, or minus 270 degrees Celsius. But the universe has a freezer. The Boomerang Nebula, a young planetary nebula 5,000 light-years away, is the coldest known natural place in existence. It clocks in at just 1 degree Kelvin, that's minus 272 Celsius, a single degree above absolute zero. It's so cold because the gas at its center is expanding incredibly rapidly, about 164 kilometers per second. This rapid expansion acts like a cosmic refrigerator, chilling the gas to temperatures colder than the afterglow of the Big Bang itself. We often think of rain as water, but the universe has more exotic tastes. Deep inside the ice giants, Uranus and Neptune, the conditions are truly hellish. The atmospheric pressure is millions of times greater than on Earth, with temperatures reaching thousands of degrees Celsius. In this extreme environment, scientists believe that methane molecules are broken apart. The carbon atoms, squeezed by the immense pressure, crystallize and form solid diamonds. These diamonds, heavier than the surrounding material, would then slowly sink through the dense, slushy mantle of the planet. So yes, it very likely rains diamonds on Uranus and Neptune. If diamond rain isn't wild enough for you, let's visit an exoplanet called WASP-76b. This is an ultra-hot Jupiter that is tidally locked to its star, meaning one side always faces the heat. The dayside temperature soars above 2,400 degrees Celsius, hot enough to vaporize metals. This vaporized iron is then carried over to the cooler, permanently dark night side by ferocious supersonic winds. On the night side, the iron vapor cools, condenses, and falls out of the sky as droplets of molten iron. It literally rains liquid iron. Not every planet has a sun. Our galaxy is teeming with billions, perhaps even trillions of rogue planets, worlds that were ejected from their home systems, and now drift through the eternal darkness of interstellar space. These cosmic orphans travel alone, unbound to any star. While their surfaces would be frozen solid, it's possible that some larger rogues could retain enough internal heat from their formation to maintain liquid water oceans beneath thick icy shells. They are ghost worlds, wandering the galactic wilderness in near total isolation. Just as planets can be kicked out of their solar systems, stars can be kicked out of the entire galaxy. When a binary star system strays too close to the supermassive black hole at the center of the Milky Way, one star can be captured while the other is violently ejected in a gravitational slingshot. These hypervelocity stars are launched at speeds exceeding 1,000 kilometers per second, so fast that they escape the galaxy's gravitational pull entirely. They are destined to spend eternity traveling alone through the vast empty void between galaxies. Earth is called the blue planet for its water, but it's a mere drop in the cosmic bucket. Astronomers have discovered the largest and most distant reservoir of water ever detected, surrounding a quasar more than 12 billion light-years away. This isn't a liquid ocean, but a colossal cloud of water vapor. How much water? About 140 trillion times the amount of water in all of Earth's oceans combined. This discovery proves that water has been abundant in the universe for nearly its entire history, existing on a scale that is almost impossible to comprehend. Our Milky Way galaxy is hurtling through space at over 2 million kilometers per hour. But where are we going? Everything in our local cosmic neighborhood, including our galaxy and thousands of others, is being pulled toward a single, mysterious point in space. We call it the Great Attractor. It's a gravitational anomaly located about 250 million light-years away, a concentration of mass equivalent to quadrillions of suns. We can't see it directly because it's hidden behind the plane of our own galaxy, but we can measure its immense gravitational tug on everything around it. Imagine a flash of light from a distant galaxy that, for a few thousandths of a second, outshines the entire galaxy itself. That's a fast radio burst, or FRB. These are intense, millisecond-long blasts of radio waves originating from deep space. In that tiny fraction of a second, they can release as much energy as our sun does, in an entire day. Their origin is one of the biggest mysteries in astronomy. Some seem to be one-off cataclysms, while others mysteriously repeat from the same location. The leading suspect? Those hypermagnetic magnetars we met earlier. In 1991, a detector in Utah registered a cosmic ray, a single subatomic particle, with an unbelievable amount of energy. It was traveling at 99.9 followed by 20 more 9% the speed of light. From its perspective, time had slowed so much that the entire 13.8 billion-year history of the universe would have passed in a flash. This single proton hit our atmosphere with the kinetic energy of a 90-kilometer-per-hour baseball, nicknamed the "Oh my God" particle. Its origin remains a mystery, as no known cosmic event in our galactic neighborhood seems powerful enough to have created it. Jupiter is a king, and it has a king's temper. Its magnetic field is nearly 20,000 times stronger than Earth's, creating a magnetosphere so vast it would appear larger than the full moon in our night sky if we could see it. This field traps a donut of intense radiation that would deliver a lethal dose to an unshielded astronaut in minutes, and its weather is just as violent. Jupiter experiences superbolts of lightning hundreds of times more powerful than any on Earth, and its auroras, driven by volcanic material from its moon Io, are a permanent planet-sized light show of deadly radiation. Black holes don't just warp space, they warp time. According to Einstein's theory of relativity, the stronger the gravity, the slower time passes. Near the event horizon of a supermassive black hole, this effect becomes extreme. If you could hover there safely and watch the distant universe, you would see stars and galaxies aging and dying in what, to you, would feel like mere moments. You would literally be fast-forwarding into the universe's future. Of course, get too close, and the tidal forces, the difference in gravity between your head and your feet, would stretch you into a thin strand of atoms, a process cheerfully known as spaghettification. Everything we can see, stars, planets, galaxies, makes up only about 5% of the universe. About 27% is a mysterious, invisible substance called dark matter. We know it's there because we can see its gravitational effects. Galaxies are spinning so fast that they should fly apart. The gravity of their visible matter isn't enough to hold them together. Dark matter provides the extra, unseen mass needed. It acts like an invisible skeleton or scaffold, and without it, galaxies as we know them simply wouldn't exist. The remaining 68% of the universe is even more bizarre. It's a force called dark energy. For decades, we thought the expansion of the universe, started by the Big Bang, would be slowing down due to gravity. But in 1998, observations of distant supernovae revealed the exact opposite. The expansion is accelerating. Something is actively pushing the universe apart, faster and faster. This something is dark energy. It's a property of space itself, meaning that as space expands, more dark energy is created, which in turn causes space to expand even faster. It's a runaway process with profound implications for the ultimate fate of the cosmos. On the largest scales imaginable, the universe isn't random. Galaxies aren't scattered like dust. They are organized into a colossal, intricate structure known as the cosmic web. Pulled together by the gravity of dark matter, galaxies are arranged in long, thin filaments and massive clusters, like pearls on a string. These filaments surround vast, nearly empty regions called cosmic voids. Our own Milky Way sits within one of these filaments. This beautiful web-like pattern, spanning billions of light-years, is the largest structure in the entire universe. If a magnet or starquake is a cosmic firecracker, a gamma-ray burst, or GRB, is a cosmic bomb. These are the most energetic and luminous events in the universe since the Big Bang. Lasting from a few milliseconds to several minutes, a typical GRB releases as much energy as our Sun will during its entire 10 billion-year lifetime. They are thought to be caused by the collapse of a massive star into a black hole, or the collision of two neutron stars. The resulting explosion launches focused jets of plasma at nearly the speed of light. If one of these jets were aimed at Earth, even from thousands of light-years away, it could potentially strip away our ozone layer and trigger a mass extinction event. We've met hot Jupiters, but let's turn up the heat. Ultra-hot Jupiters orbit so close to their stars that their years last less than a day. On a planet like Kelt 9b, the dayside temperature exceeds 4,300 degrees Celsius. That's hotter than the surface of most stars. At these temperatures, molecules like water and carbon dioxide are torn apart. The atmosphere itself begins to ionize, glowing like a star and forming a massive comet-like tail of evaporating gas that is being permanently stripped away into space. These are worlds literally boiling away into nothing. Remember neutron stars? Some of them spin incredibly fast, hundreds of times per second. If they have a magnetic field that isn't aligned with their spin axis, they can shoot out beams of radiation from their poles. As the star rotates, these beams sweep across space like a lighthouse. If one of these beams happens to sweep across Earth, our radio telescopes detect a regular pulse. These are pulsars, and they are the most precise natural clocks in the universe. The best millisecond pulsars are so stable, their timing rivals that of our best atomic clocks on Earth, making them invaluable tools for testing the limits of physics. This might be the most profound fact of all. Because of dark energy and the accelerating expansion of space, most of the galaxies we can see in the sky are already forever beyond our reach. The space between us and them is expanding faster than the speed of light. Light from them can still reach us for now, but we could never ever travel there, even if we had a ship that could travel at light speed. Over cosmic time, more and more galaxies will cross this cosmic horizon, their light red-shifting into oblivion until, in the far distant future, our night sky will be empty of all but our closest galactic neighbors. We are living in a brief privileged moment where we can see them at all. So, let's recap. We've seen mountains crushed into teaspoons, stars that quake with the force of 100,000 suns, planets where it rains diamonds and iron, and an entire universe that is running away from itself. We've journeyed to the coldest place in existence and witnessed particles with the energy of a baseball. Each of these facts is a testament to the sheer, unadulterated weirdness of our cosmos. The universe is not just stranger than we imagine, it's stranger than we imagine. If your brain feels slightly melted, in the best possible way, and you're hungry for more cosmic insanity, make sure to subscribe. There's always another layer to peel back. See you in the next deep dive.